we have another beautiful 3D printed custom LED project. This cylinder comes with an external remote that is powered by AA batteries to control the lighting. It uses radio frequency to transmit data between two Arduino Nanos. The fully 3D printed remote has the ability to change the brightness as well as control many different animations and produce many different colors. I'll first share how the 3D printed controller works, then I'll move on to how the cylinder was built. Let's get started. So the controller works by having the ability to memorize what page it's currently on. The Arduino Nano first starts off on page 1, which will display a different set of solid colors. Changing the page will change what the buttons will do. On page 2, the user has the ability to display a custom color of their choosing. They are able to control the RGB values. Pressing button 7 will decrease the red in the custom color, while pressing button 8 will increase it. The same follows for green and blue on buttons 9 through 12. On page 3, we have gradient colors which fade from one color to another. This is similar to page 4 where we have gradients, but using 3 different colors. Finally, on page 5 and 6, we have fancy animations. On some of these, we can press the left button and it will display a color and run the animation. If we press it again, it will change the color of it. If we press the right column button on the same row, it will repeat the animation, but automatically switch colors instead of manually. I decided to program it this way so the user has flexibility and can choose if they want to manually pick specific colors or not. Overall, I have a cheat sheet that can be downloaded and found on my website neha.com. Here you will be able to find all of the downloads ranging from the code to the 3D prints and the documents. Don't forget to check out my other projects as well. Now we'll move on to how the controller was constructed and planned. I decided to have the controller use 3 AA batteries as well, but I soon realized that the controller would be quite bulky. You can always use a boost converter from 2 AA batteries, which will boost the 3 volts to 5 volts. This will be more reliable and would result in a less bulky remote. Moving on, we have the Arduino Nano and the NRF24L01. I was able to solder these to a motherboard that I ordered online, and don't forget that all of these links will be available on my website along with the wiring diagram. I originally thought it would be cool to have a potentiometer on the remote to control the brightness, but I soon realized that I could just control the brightness with the buttons, which will make it more consistent with the theme of the remote. When it comes to soldering components, I first added header pins to the Arduino, which I would eventually solder to the first motherboard. The overall soldering process took quite some time and may have been one of my longest soldering jobs so far. Once I got the Arduino pins, I had to solder the NRF24L01 to the motherboard as well. Once I got this process done, I used speaker wire as jumper wires for my long connections. As a disclaimer, I highly suggest using jumper wires instead of speaker wire. It works much better and is more durable. I learned my lesson the hard way when I had to continuously solder new wires to the project because the other ones kept breaking. Plus, it took longer to strip every wire, twist it, pre-tin it, and make sure it's not in the way of anything else before soldering. In the long run, just get some jumper wires, it'll save you. After I got the first circuit board wired, I moved on to the next one, which was much skinnier. This will house the right side of the buttons. I aligned each button and soldered a positive connection to them with a resistor in line with each new button. For the buttons, I used small tactile buttons which can be found on Amazon for cheap. I especially like this set because I got a variety of sizes and they should fit for mostly all projects. They easily snap into place on the motherboard, which was nice. Once this was completed, it was time to connect them to the main circuit board. I soldered more pins to the Arduino and connected them. This could have been done beforehand, but I didn't know exactly how I wanted this project to be done yet. Once I got the other side of the buttons done, it was time to test. Before I do any wiring, I usually test on a breadboard to make sure everything hooks up correctly. So all I had to do was upload the code and see if I got the correct results. I also then created a 5-volt battery pack that I can attach to the remote to use and test. This is the standard battery pack that I developed and use for most of my projects. The LED will turn on when the user presses a button to signify that it is connected to the device and is sending signals properly. It also flashes every 10 seconds to let the user know that it's still on. Otherwise, it can be a little tricky to remember in case someone leaves it on. I built this project in mind to connect the parts using small screws instead of glue. I think it's more professional to have projects using more screws rather than glue. I also 3D printed orange button caps along with the white LED cap. This helps the user press the buttons and to not get blinded by the blue LED. The buttons on the controller work by sending a signal through the row, and each button has a 20 ohm resistor. I can detect the signal on the Arduino on 2 different pins. The first pin will control the left side and the other pin will control the right side of the buttons. When the first button is pressed, it has the most voltage attached to it because it has no resistors attached to it. When the next button is pressed, I can get the signal and determine that it is less than the first signal, so I know it's button 2. Finally, at the end, I know when it's pressed because it has the most reduced signal to it. One problem that may occur is that the batteries are dying and the number of the resistance will be off in the code. I've now covered how the remote was built, and now let's move on to the cylinder and how that works in conjunction with the remote. At the bottom of the cylinder, we have a 1 amp switch with 6 different screws. The inside 3 screws allow the lid to be screwed on to the inside of the cylinder, which houses the Arduino NRF24L01 radio frequency transmitter and the 3 AA batteries. Next, the outside 3 screws allow the cylinder to be screwed in place inside the whole white container in the center. I had to test using trial and error on how big the container should be and how far away the LEDs on the inside should be. This is important because the light emitted from the diode will be diffused a certain amount. The closer it is, the more you can see the LED. On the other hand, the farther away the LEDs are, the more blurry and diffused it will be. In total, I decided to use 48 LEDs with an LED on top. I originally did not have this LED there, but it was too dark on top. This was the case because I did not add enough room between the inside of the cylinder and the top of the outside. If there was room, then the light would be able to be shown through the top. The cylinder was a pretty basic design, so there's not much to cover for this one. Overall, this was a great learning experience for me, and I had a great time using all of this. This is a beautiful project and is great for a desk at work and to show off to your friends. Let me know what you think about this project. Don't forget, I have all of the links and files posted on my website, neha.com. I hope you all enjoyed this project. Don't forget to like the video and subscribe for more amazing projects. Thank you for watching, and I'll see you in the next one.